All right, everyone, the next topic is finding the equation of a normal line. And to do this, we have to know what a normal line is. So here's our definition. The normal line to a curve at a point is the line perpendicular to the tangent at that point. So let me just draw you a quick picture here. Let's go ahead and say we've got the graph 4 minus x squared, which is kind of the situation that's given to us above. That looks like this. And then we've got our x equals 1. And we've got some sort of tangent line. So the normal line is going to be perpendicular to that green line. In other words, it's going to look something like that. We've got a perpendicular. So this blue line right here is the normal line. Now, some of you might say, what's the point of this? Well, there's actually quite a few applications in physics, and mainly that of gravity. Gravity pulls at a perpendicular motion, and so those would be the applications. I'm not going to get into that too much now, as we will have a unit on applications, but let's go ahead and let's do this problem. We're just going to do this exactly the same way that we've been doing it on the previous slide, where we're using this formula right here. So I'm going to have my limit as h approaches 0 of f of, let's see, my a is equal to 1 here. So this is going to be 1 plus h minus f of 1 all over h. All right, so we are now going to plug in 1 plus h into x, so we get 4 minus 1 plus h squared. And now I got to plug 1 into x, so I get 4 minus 1 squared. Well, 4 minus 1 squared is 4 minus 1 is equal to 3. So we've got the point 1 comma 3, and I'm going to have minus 3 here. All right, next thing we're going to do is divide by h. And I'm going to now do FOIL with 1 plus h squared. So 1 plus h times 1 plus h. And so first outer inner last gives me 1 plus 1h plus 1h plus h squared, which is 1 plus 2h plus h squared. So I'm going to have 4 minus parentheses 1 plus 2h plus h squared, and then minus 3 all over h. We're going to have to continue with simplifying here so that we can get some h's to cancel. So this is going to be the limit as h approaches 0 of 4. Now let's distribute this. So it's going to be minus 1 minus 2h minus h squared minus 3 all over h. Okay, we're crossing our fingers that things cancel. The 4 minus 1 is a 3, and then we subtract 3, so that's good. Those all cancel. And now I'm just going to pull out an h in the numerator. So that's going to be an h. That's going to be negative 2 minus h, so I just pulled out an h right here. And then in the denominator, I have divide by h. Of course, our h's cancel. And now all we're left with is plugging that 0 in for h, and we're just left with a negative 2. So that's our slope of our tangent line. But actually, I want the slope that is perpendicular to that. So you've got to remember Missy Elliott in her perpendicular line song. She says, put your thing down, flip it and reverse it. So if this negative 2 is the slope of our tangent line, the slope of our normal line is going to be m equals negative 1. Oh, sorry, just positive 1/2. Right, I took negative 2 and I flipped it to be a 1/2, and I changed the sign from negative to be a positive. So I flipped it and reversed it. So now let's go ahead and write the answer. So this is going to be y minus my y1, which is 3, equals my slope of 1/2, and then x, and then here's my minus 1. And that's going to be the equation of our normal line. Here's an actual picture of it, and obviously the green line is the slope of the tangent line, and you can see that that has a slope of -2. You can see it's down to right 1, down to right 1. But our blue line is going to have that slope of a positive 1/2, which is up 1, right 2, up 1, right 2. And so that blue line again is called the normal line. All right, let's do another one. So write the equation for the normal line to the curve f of x equals -3x squared. All right, and that's at x equals 1, or you can think of this as a. So we've got the limit as h approaches 0 of f of 1 plus h minus f of 1 all over h. So I'm going to plug in 1 plus h in right here, and I get the limit as h approaches 0 of a -3 times 1 plus h squared. Plug in 1 now, and I get -3 times 1 squared. Well, do the squaring first, and that gives me 1. And -3 times 1 is -3. So I've got the point 1, -3. So this becomes a -3. See, I almost made that mistake. You've got to put, and I want to emphasize this, the minus down first, and then you've got to put down your y value here, which is that -3. And you go, oh, that becomes a +3. And that's kind of the common mistake in this problem. H. Now, just for sake of time, I'm going to do the FOIL in my head. That gives me a -3 times, that is 1 plus 2h plus h squared plus 3 all over h. All right, now let's go ahead and do distributive property. It's help if you make those noises. So this is going to be -3 minus 6h minus 3h squared plus 3 all over h. And we rejoice now because we've got a -3 and a +3 that cancel. And now I'm going to pull out my h. That gives me a -6 minus 3h all over h. The h's cancel. I plug in my 0 now, and when I get that, I get -6 minus 3 times 0, and that just gives me a -6. Okay, well, if I have -6, what's the opposite reciprocal, or as Missy Elliott says, put your thing down, flip it, and reverse it. I'm pretty positive that's what she's talking about. So that's going to end up being a slope of 1/6, right? This was negative, now it's positive. It was 6, now it's 1/6. All right, so our final answer is going to be y minus -3 equals a slope of 1/6, x minus 1. Well, y minus -3 is y plus 3, and this is our answer. Let's check it with the graph. All right, so our tangent line is this one right here that I'm drawing in orange, and we should have a slope of -6. So does that look true? Down 6, right 1, down 1, 2, 3, 4, 5, 6, right 1. Perfect. And then it's a little bit hard to see on this, but this one is a up 1, right 6 slope, and that is our normal line. The one that I'm highlighting right now is our normal line. This is that equation. All right, that's it for now, folks. Hope you have a splendid day, and make sure you eat lots of chocolate. Okay, bye now.